Okay. Before we go into monitoring, we'll try to understand some concepts like observability, okay, then reconciliation. Okay. Um, does anybody know these concepts beforehand?
Sir, like you said, today's class will be about how to read logs,
Sorry?
like how to read that CloudWatch logs or how to
Hmm.
read. Oh,
Why? What happened? Why are you so amazed?
like uh, okay, I thought like this was taught like on the job only. Like this was a subject I didn't know. Like this was okay. No issues, no issues, sir. No
Okay, okay.
issues.
Okay, great. Okay. So let's look at observability reconciliation. I'll give some basic intro examples and then we'll go to what observability and reconciliation is. Okay. So take a basic program. Okay. How do you capture an exception? Anybody? Any examples? What do you do to capture an exception? Imagine there is an error in your code which you don't know, but you want the compiler or underlying interpreter to tell you where that error is. You have to write your code in certain syntax code block. Do you know what code block it is?
Sir, we use try catch.
Wonderful. Try, catch, and if you're using JavaScript, you have finally also. Okay. Try is the logic which underlying compiler or interpreter will try to sense. Okay, remember this word sense potential known errors. Okay, what are known errors? Syntax, right? Semantic. What are semantics? Syntax is if you're writing if and else. If your if is written as fi, unless it is bash. Okay, if you're writing phi in Python or phi in C, your syntax will throw an error. Okay. Similarly, if you are using if and then you started for and then you didn't close for, didn't close if, and then just written else, then this is a typical semantic error. Okay. It expects you to define the known statement within its scope. So if you're writing if, the scope of if is if judgment condition, bracket open, bracket close, then else, bracket open, bracket close, in typical language, right? You can't avoid this semantic and inject something else. Otherwise, the underlying compiler or interpreter will assume that you are using something wrong. So typical compiler sense, they have a sensing job, or it has underlying logic to detect syntax errors, semantic errors. Okay. How do they do that? Using static code analysis. Okay. Static code analysis, there are many static code analysis tools. You can try in Perplexity or you can try it in GPT or in Google to see what they are. I don't want to go into this detail, but there are static code analysis tools which will also do semantic syntax check. Your underlying compiler can also do semantic and syntactic check, but there could be some other issues which are beyond semantic and syntactic. Okay, they are typically unknown issues. Okay, unknown issues are logic related. Okay, logic construction. For example, if you want to multiply a into b, okay, if your pseudocode or if your requirement is to multiply a and b, but in the code you are multiplying a into b. Okay, as per syntax this is not wrong. Okay, as per semantic this is not wrong. Mathematically you have to do this way, or instead it should be star, not x. Okay, but when it comes to logic, you will only detect this using either you when you do unit testing, or if you miss that unit testing, you will eventually do it when you go to alpha or beta testing with the QA team. Okay, that's where they look at the logic, they have the requirement, then they eventually check whether it's passing or failing. Okay, same concepts which you already know, where people eventually use try, catch, and finally blocks. Try is the place where it will help you do the known error check. Okay, catch is where whatever error this is, it will eventually have error codes. Okay, if you're using HTTP for our basic understanding, you have codes from 0 to 1000. Your typical code 200 is success, 500 is page not found, 401 is unauthorized. You have so many codes, right? So typically that takes care of catch. Irrespective of what error is caught, you want to just print whatever you want, you will end up using finally block. Okay, so in conventional programming, exceptional handling will help you log whatever is happening with your code in one place. Okay, that is how typical logging was introduced in procedure oriented languages and in object oriented languages using try, catch, and exception, try and catch block. Before try catch block, I mean, when try catch block was didn't exist in conventional programming like C, Fortran, or ABC, B programming language, Basic, COBOL, people used to write print statements after every code block execution. Like for example, you have a calculator program. You created one, let's not use class, it is object oriented. Let's use a function called cal, okay? And you are reading an input A, B, and you're passing it to another function called sum. And inside sum, let's assume you're doing z is equal to x plus y, okay? Now, conventional procedure-oriented programming languages, they used to write print statements when they want to do unit testing. Okay, so they used to write the control entered into cal function block. After read A, print statement. Reading of A is completed. After B, reading of B is completed. In the sum function, they used to print entered sum function. After the addition block, then they used to print sum was completed. So this is how typically they used to log in conventional program like 30 or 35 years ago. But when try catch was introduced, the error logging became more beneficial. Okay, when these programming languages like Python, Java, and eventually their web variants like Jasper, Java server pages, servlets, structs, all other frameworks, when they came into picture, they also tried to use try catch type of an approach, but it was not helping them a lot. Why? Because to understand or detect syntax or semantic issues, you have to run the code, you have to compile the code. Okay, without compiling the code, the try catch block will never run. Okay, so the problem statement they have is, what is the problem statement? How can I detect the error without even running the code, or detect the error when the program is continuously running? Okay, assume that there's a program which is continuously running in a recurring fashion, but in that recurring fashion, I should be able to log certain errors which only I want. Okay, which only I want. It can be for example, if you look at errors, typical errors are from low level errors to strong errors, like mild, strong. Okay, like in general case, you have orange to red type of category. Now if you want only red type of an error, it's very difficult to capture in at least 10 years ago. If you had too many try catch logic, you have to actually compile them. Unless until you don't compile, you typically don't get those errors. So that was a problem statement. So when all these web programming languages offered SaaS, when they started offering running the code on demand, shared, it became difficult for them to sense without executing the code or detect the errors on the continuous recursively running programs. Okay. So what they have done, they have introduced the concept called observability. Okay. If you look at observability, what is observability? Observability is a technique for you to detect the errors in different forms. Okay. How, for example, there is a one type of observability error detection or sensing called heartbeat. Okay. And there's another type called sensor. Okay. Then another type called heap. These are some types. Okay. We'll go into these in detail, why they are named like this, what is their uniqueness, where you have to use them. All these things will eventually go. But in general, just understand that observability is a concept which involves in strategizing, error logging, system health check, check whether the systems are up or down, ability to determine whether my machines can scale or not, do I need more infra or less infra, resource utilization, etc. Okay. The first variant of observability was actually introduced in Linux machines and Windows machines using what we call task manager. Okay. um, did you ever use task manager before? Yes, no?
Yes, sir.
Okay, so if you open your typical machine, you will find task manager. Okay. This task manager contains heartbeat, sensor, heap, kind of a observability indices which were introduced in early operating systems. People who were using SaaS platforms or introduced cloud platforms, they actually copied. I mean, a copied is a wrong word. They got inspired through these sensing alerts, daemon alerts, and try to mimic them on cloud system as well. Okay. So that is why you will see whatever you see in your typical Windows task manager, you will typically see them in cloud platforms. Okay. We'll first look at some examples, then we will go into each of them in detail. Okay. First, we'll finish observability. So let me show you one example of status pages. Okay, this is one example of status page. There is one more example of status page. I'll explain them in detail. Just give me 1 minute. Then let's look at our favorite Zoho and Salesforce. Okay, New Relic. We'll go to them one after the other. Then you have what else? Okay, these are enough. Okay, let's look at LinkedIn first. Okay, LinkedIn, as you all know, is a SaaS platform. It allows you to access the platform, authenticate through email. They host their servers in Microsoft Azure. And if you observe, there is a page called linkedin-status.com. Okay. What this website tells you is, it tells you that the typical website is operational. If there are any underlying issues, you will see something red over here. Okay. You can see the API statuses. Okay, they don't have much detailed status page. This is very, very simple status page, okay, which will tell you what is the health of the website. But if you go back to Salesforce, Salesforce has too many products, okay. So if you see, Salesforce has an integration product called MuleSoft. So looks like MuleSoft is down. It has some incident because of some server issue or some issue. So if you see, this is how typical observability pages are maintained. So Salesforce is telling you today, as we speak, their MuleSoft software, which they host in cloud, has an issue in USA region. Its endpoint services and observability suite are down. Okay, so if they have something like this, it means that there's a performance degradation. Okay, if they're in green, it's actually in the available state. Okay, so very good example. Good that we figured out. If they are maintaining something, if you're bringing the servers down, we'll talk about maintenance also, how people do maintenance in some time. You will find this symbol. Okay, so you can sort by region so that you'll eventually know how the health of the services are. Let's look at something else. Let's look at Salesforce services. I think all services are up, they're not down. Okay, so this is how typical trust pages are maintained. Okay, let's look at Snowflake. Snowflake is a database offering database system, like how Microsoft SQL Server. You have Microsoft SQL Server is a standalone implementation. Snowflake is a cloud version of a database. Okay, so in the cloud version of database, you eventually have DBs shared across regions. So if you observe carefully, Snowflake is hosting its SaaS product in USA alone in two regions, Iowa and North Virginia, in Europe, London and Hemshaven, Frankfurt, and in Middle East, it is Dammam, Bahrain. Okay. So that is in Google Cloud Platform. If you look at Azure, in Azure, they are maintaining in one, two, three places in US, four places in US. If it is US government, it means that they have dedicated instance for US government or government products. Okay, so all Snowflake related government databases will be sitting on Azure US government in Virginia. Okay, so that's how you have to look at. So if you observe, these are the products Snowflake has, and all of them are healthy right now. Okay, you see green because they are actually using a sensor. It's a sensor job which will run in the backend, which will actually sense and give the output. And it also has an offering in AWS. So these are the regions it covers. Okay, so if this is a legend of the status page of this Snowflake. Okay, let's look at Zoho. Zoho is also a CRM kind of a platform where it has expense management, it has billing software, etc., etc. There's something called Udo also. Status. Yeah, Udo also has its app status site. So yeah, it's telling it is up. Udo available. Udo.sh is up, on-prem is up, but online is down. So this is how they maintain the monitoring sites. And if you look at Zoho, Zoho tells everything is up. Okay, this is how companies SaaS products provide their service status of their services to show things are up. Now we'll go and see how observability is actually done in practice. Okay, so let's look at an example. Let's look at Zoho. Okay, so imagine Zoho has a product called expense management system where you can submit all your expenditure tracking system. Okay, now imagine it has a website, it has a web, it has a database. Okay, sitting in cloud. Let's assume all of these are sitting in one container. Okay, and this is one pod. Okay, this is one pod, and this is container 1. Let's assume this is container 2. This is web and DB, and assume this is pod 1, and this is in the Kubernetes setup. Okay, so what they will do is they will define this container to one region, US Virginia. Why do you take US? Let's take South India. South India access. So everybody who is coming from South India will hit this container. Let's assume there is another container for South India too. Okay. Now there is a layer in between. So there is a layer in between the target user that's called load balancer. Okay. So all the people who are coming from South India, from Karnataka, Kerala, Andhra Pradesh, Telangana, Tamil Nadu, their requests are routed through this load balancer. From this load balancer, the load is dissipated by 50 to 50%. Okay. Now they'll hit container 1, they'll hit container 2. If the traffic is high, let's assume this container has capacity to take 1,000 threads, like 1,000 user accesses. And let's assume this is 1,000 user accesses. And if 10,000 people are accessing it, then this pod will run out of its efficiency in delivering the service. Okay. So what happens? Someone has to write a health check job on this pod. Okay. That guy is a DevOps engineer. What this guy will do, he will write one small service, one .bash sh file. What does it do? That batch sh file will go to this folder location of the container. Okay. This container will have some system files, device files, div.log, div.log. Okay. So the DevOps guy will write a batch file to go to this pod 1 container 1 dev log file, pod 1 container 2 dev log file, and he will write a command to read the text and count the threads. Okay. So this script, let's call it heartbeat.script. Okay. This heartbeat.script is running in while loop. Okay. Infinite while loop. He says true is equal to 1 and that loop will run forever. Okay. When the loop will break, when the judgment condition in the loop, if the thread count is greater than or equal to 1,000, then the while loop will break. When the while loop will break, in the .sh file, he will send a signal or he will print a value that things are going for toss. Okay. When the print comes in the console, the status page, right? The status page, like how you have seen for Zoho, will change into disruption or partial outage or under maintenance. Okay. So people typically write bash scripts to maintain, manage the health of the pods in Kubernetes setup. Kubernetes gives you an inbuilt sensing jobs. Nobody uses the inbuilt sensing jobs because they are very, very simplified in nature. The DevOps engineer will customize them because the thread counts, typically the user access counts, vary from one customer to another customer based on the infra. Okay, because Zoho might can afford 1,000 only, let's assume. There's another company called Sai Corporation that can afford, let's assume, 10,000. Okay, rather than affording 1,000. So when 1 lakh users come to the load balancer, the sensing job will go and throw the errors in its infinite loop. There are the threshold has been reached to its optimal level, so you have to throw a flag. So when the print statement gets executed, it will also run a connected script called a kill jobs or maintenance jobs, maintenance page jobs. Okay. What happens when the while loop throws an exception? It executes a maintenance page job. Then the load balancer stops taking additional requests. Okay, so they will kick that job as an input to load balancer, so that it throws a maintenance page. Okay. How many of you all have written JE exam?
So I have written.
Okay. Let's assume among 29 people from the class might have written JE exam. Okay. So you might have accessed the JE results website. Yes or no?
Yes, sir.
Huh. How was your experience in accessing JE website? Is it very responsive, or is it never used to load?
Sir, it gets down during the result time.
Huh. So what's happening is, if 29 people access that server, there's no problem. But if 2,99,90,000 people access that website, it goes down. Why? Its underlying RAM and ROM have no ability to create those user threads in its temporary session. So what the typical IIT Kanpur does, the results website, they should actually buy a load balancer, keep this server into create this server as multiple containers and keep them in multiple pods. Okay. So that, people like 2000, 2,900 try to access, the load balancer will eventually direct them to respective containers and give them results on demand. Okay. That is how the SaaS products avoid disruption. Because JE results website is not a product. All they are there to just give you a scorecard. That too, once in a, I think maybe people access that website only for at a peak time of 2 to 3 days, right? On the day of results announcement till the end of that week. After that, nobody's going to go to that site. So that's why they don't buy a load balancer. That's why they don't get more containers. That's why they don't set up a Kubernetes network to manage their traffic. Okay. But what SaaS products do is they maintain observability. Okay. So first example we have seen is a heartbeat. What is heartbeat? You can correlate this with your human heartbeat. Human heartbeat is actually telling itself that it is alive. Okay. What heartbeat tells you? That I am alive. So basically, nobody is going and checking whether the job is running or not, but the job itself is telling the world that I am alive. That is called heartbeat job. Okay. What heartbeat jobs typically do? Heartbeat jobs will are typically written in containers to tell whether the container is up and running or not. Okay. So if you look at the task manager carefully, task manager gives you an heartbeat. All these are heartbeats. There is a small job which will go and query the log of a CPU a system utility file, and it will return these values every second. So these are called heartbeat jobs. Okay. Similar heartbeat jobs can be applied on a container. Okay. Like how a CPU log is being responding by querying the log file. Similarly, in the eventual containers dev.log file, you have all exceptions being thrown here. People will write a bash.sh file. Let's take heartbeat.sh file to go check the log. If the log says success, or if there are any successful messages, it go and throws the message to the respective monitoring tools. Okay, remember this word monitoring tools. Okay, what are those monitoring tools? One good example I can show you is Grafana. Okay, Grafana, Faro, ClickHouse, all these are monitoring tools. They actually help you visualize the content which is present in the log file in a user interface. Okay. So if you look at this example, which I'm trying to show you on my screen, is actually a heartbeat sensing job responses of bunch of machines which are being operated in one company. Okay. There's a company which actually has these products. Okay. It has a CRM, it has a HRM, it has a APM, it has multiple products. We are actually trying to see the sensing job responses. So the heartbeat, someone has written a bash sh file to check how much time it is taking to I think what is this? Time to first byte. So for example, there is a job which will go and ask for some data. Now how much time it took for a service to return that first byte is what you see here, 195 milliseconds. Okay. So let me remove control Z. Okay, Grafana is one such tool where people write heartbeat jobs to visualize. There is another good tool called Splunk. Okay, I don't have Splunk access, but I can show you Splunk dashboard. So this is how typical Splunk dashboard looks like. So Splunk will offer variety of heartbeat jobs. All you have to do is supply Splunk or a tool like Grafana or a tool like ClickHouse or Faro, the log files of your product. Okay, you have to supply the log of the container, log of the pod, log of your load balancer, log of your database, log of your web server, so that it will come back and pre-calculate all the metrics it can do: turnaround time, response time, uptime, average user engagement time, number of in a given 1 hour, how many people have touched that site in given 1 hour, how many times the how much amount of bytes was responded or downloaded from that site. All that info is typically read from the monitoring dashboards. Okay, this is our typical heartbeat jobs work. Okay, any question with heartbeat job?
Sir, hello, sir.
Yeah, yeah, tell me.
So, like, heartbeat doesn't necessarily mean that it is related to hardware only. Like,
No,
you
no,
said,
no, no, no.
like
Not
Splunk.
hardware. Not always hardware. Hardware is one example.
Okay, okay.
Yeah. So you can also do a heartbeat for software. I'll give an example. You have any further question?
No,
Sorry, I didn't let you complete the
no,
question.
no.
Sorry.
Actually, I worked on Splunk, so I
Oh, good.
always I didn't know that Splunk was a monitoring tool. Like,
Yeah, it is also a monitoring tool.
okay, okay. Huh,
Yeah.
no issues.
So what did you do with Splunk?
Actually, sir, we used to, sir, I have industry experience. We used to monitor threats for Gap,
Mm. What
like,
threads there? Web
like
threads?
who the Gap developers who have logged in from where,
Those are
the session
session.
monitoring, session monitoring.
Got it. So
Like,
I'll show you one example. That's a good point. So that is typically, I'll show you one product called Heap. Okay. So what you have used with the Splunk is,
sir, can I tell one use case? Like
yeah,
what?
yeah. Go ahead. Please tell. Please tell.
Like
Yeah.
like we used to, like, if one developer has logged in from Kolkata, then
Hmm.
if suddenly from his account a developer has again logged in from even from Chennai, we used to flag that and then ask them over mail or something like that. Like,
Hmm.
what is the reason why are you using different locations to log in?
Got it. Got it.
Like, this was the simplest of
Yeah,
them.
yeah. Got it. Got it. So I'll show you one parallel example. So what Splunk actually does is observability plus user adoption and user events. Okay. So Heap is one such platform which actually helps you check how many people logged in, which pages they're looking, what are the average users, who are they, what are they doing, where are they navigating. There is also another tool called Pendo. So what Pendo does is it's actually also does the experience management. Splunk is actually a observability tool which also does the user experience management. Mm, Pendo dashboard. Yeah, so you see it talks about logins, feature adoption, how many people visited, weekly visitor users, etc. etc. Okay? This is also an observability from a user management perspective, from traffic perspective. You can also do observability. Okay, I think I have to, uh, I'll give some good examples. So if you look at observability as a whole, you can do observability of a SaaS platform from user accesses to study who are accessing, who are weekly active users, daily active users, monthly active users, what pages they are accessing, how are their journeys are. Okay, for example, to book a cab, if there are 5 steps to perform: log in, search for target location, choose the cab, and then wait. Let's assume this is the flow. But the observability tools will also track the user journeys. The ideal path might be 5, but the user might be using 15 steps. That type of click data you can get through observability tools, okay, for user access or user sessions or user behavior, etc. There's other type of observability which you can do is error management and health check. Okay, error management is to check which site is down, which is up, when it is down, how long it is down, how long it is up. Health check will actually tell whether the who is the traffic, where is the traffic coming from, how should I dynamically manage the traffic, uh, and how I should do load balancing, etc. Okay, so on the whole, that's a good point someone brought up. Typically, observability take care of all these things, but the example which I spoke about is heartbeat, where it will do the sense by itself. It will tell the world that yeah, I'm alive, I'm not dead yet. So when the heartbeat stops, it means that some hardware or some software service which has an heartbeat alert is not working. It means that it is not responding. That's where the health page statuses will show red or unavailable. Okay, so this is typical heartbeat. Okay, now let's look at something called sensor jobs. Okay, sensor jobs are like they hold a similar annotation like what sensor is. Sensor is something when it always be watchful of some specific event. Okay, and when that event occurs, it captures the log. Okay, for example, imagine you went to a shopping mall, and when you are here, there are slide doors which will automatically open because there will be a sensor which will sense your presence maybe 2 feet from the door. Okay, so the sensor will be watchful all the time for an event. What is that event? uh, an object should enter the range of 2 feet from before the sliding door. Okay, once that event occurs, then only it will log the event. Okay, these are sensor jobs. Okay, typical examples for sensor jobs is high traffic management. Okay, example, you have a results website. Your website is designed to manage 1,000 logins per hour. Okay, if your logins are reaching more than 1,000 per hour, then the sensor will throw an error and kill all the other logins which are beyond 1,000. Okay, for example, at 9 a.m. to 10 a.m., 900 people access, the sensor will sit idle. From 10 a.m. to 11 a.m., 9,000, not one person is trying to access, then it will kill the access of that one person who is coming between that 1 hour. That is where the sensor will detect and tell. It will not, it will take a respective action defined in the sensing job. Okay, how does the sensing job look like? Okay, sensing jobs are typically written in typical for loops or if and else loops. Okay, so what is if you have a judgment condition? What is the judgment condition here? If an object is found in the 2 feet radius or 2 feet length of a sliding door, do this action. If not, else do nothing. Okay. So all your bash HS scripts which are written for sensing jobs either use if else, classic if else, nested if else, or for loops. Okay. So for every iteration it will check. Like for example, it would be a bad example, but in your washroom, when you go for a pee, there is a sensor. When you move away from the sensor, the water will flush, right? So that is typically a for loop. It will go for every iteration, it wait for 10 nanoseconds or 10 microseconds. After 10 microseconds, the sensor will flush the water. Okay. So all the sensor jobs are basically written in bash using conditional if else or for loops. Okay. So these are two simple examples in observability. Okay. Any questions before we go to reconciliation?
No, sir.
Okay, let's go to reconciliation. Okay. One big problem in monitoring, especially data products. Okay, monitoring data products is very, very critical if you don't have a reconciliation module. Okay, what is reconciliation? Let's take one data product. Okay, a reporting tool. Okay, so there is a source database, like let's take NIT Tiruchirappalli's attendance management system. All students log into this system, mark their attendance and log out. Okay, imagine there is a database. This database is transferred into a warehouse. Okay, data warehouse. Now there is a website attached to this. Everybody goes to this website, mark the attendance, and then the data comes and sit in this attendance tracker database. And every night there is an ETL job which will push the data from this table to this DB. And a reporting tool was attached to it, like Power BI or tools like Tableau. Some reporting tools are attached to see who gave attendance to DevOps class on 13th of March, who gave attendance to DevOps class on 10th of March. That data they're trying to see here. Okay. Now, what is reconciliation problem? Imagine there is a table called attendance. Okay. And that table has 1000 records. There is an ETL job which is run, and we assume whoever is maintaining database is assuming that all the 1000 records have reached the destination table, and the report is being run on this destination table. But if you don't maintain the tally check between the source and the target, you can never tell whether the attendance you are seeing in the reporting tool is genuine or wrong. Okay, because you have no way to see the attendance in the UI. You can only see in a reporting tool. But what if the reporting database has only 800 records? Your 200 records may be missing because of an ETL job due to some bug which you don't know. Okay, so that is where this is the use case for you to set up reconciliation. Okay, how do people write reconciliation jobs? These are typical SQL jobs which are written to log how much of data is going from target to source. Okay, they are typically written in ETL jobs or batching using tools like Airflow or SSIS, Microsoft SSIS, or there are additional tools like Spark data batch processing job, or Flink. Flink is one more tool, FLINK. Okay, which is a batching software which will read the data from source, moves the data to target. Okay, now let's see how typical recon jobs are written. Imagine you have a source table table contains tuple 1, tuple 2, tuple 3, and you have a target table, you have no tuples here. Okay, the job of an ETL is to extract. How does extract works? Let's give the name to this table, ATT. You have target table ATT. Now our task is to move this tuple 1, 2, 3 to here. Okay. How the typical extraction module works? It selects star from ATT. Okay. And then you have transformation. What transformation you want to do? Let's assume you want to, there is a flag called attendance 1. Okay. Now when it comes to the attendance, you have converted that column to present or absent. Okay. So in the transformation logic, you will write select case ATT, if ATT is equal to 1, then present. If ATT is equal to 0, then absent from ATT. This is my transformation logic. Okay. Then I will have load logic. What is load? You will take the same block. Okay, you will take the same block, but you will do insert. Insert into ATT from select case ATT. Okay, so this is my load job. Okay, so I'm reading
Sir,
tuple 1, 2, 3. Yeah,
sir, can I like ask a different
yeah.
question?
Go on. Tell me.
Like, sir,
Tell me.
do you know when do in ETL jobs when do you use upsert and when do you use delete and insert?
So yeah, so there are, so what I'm talking is ANSI SQL. Okay,
Okay.
if you are using Snowflake, there is a concept called merge on target, merge and delete, copy on read. Okay, there are two techniques.
Uh,
Okay,
uh,
what I'm talking here is CDC, change data capture, which is different. Okay, what was your question?
like you are
Merge.
here, here you are just like saying that insert into like this is an
Huh.
update. No? This
Yeah,
is
this.
up.
Yeah, this is, see, I'm giving a very naive example
Uh,
so that everybody will understand. In simple ANSI SQL, which is typical insert. Okay, so the core and mod are available in advanced databases. I don't think people will get confused. Okay, I'm
okay,
just very
no issues,
simple.
no.
Yeah.
Okay.
So this is a very simple example for everybody to understand. There is a simple select. There is a transformation where I'm manipulating a column and I'm doing an insert, which is my load. Okay. Now our question is not to understand how ETL works. Our problem is how do you do reconciliation. Okay. Now when you do select, you have to log the count of star. Okay. So when you do select star from ATT, you will also have to pass another statement, count of star or count of one. Both are same. When you do count of star, the table will actually scan 1, 2, 3, 4, 5, and it will give one row. 1, 2, 3, 4, 5. Second row. The count is 2. When you do count of 1, it will not count the entire row. It will only count the first column. It will tell 1, yes, 2. The count is 2. This is count of 1. So you either do count of star or count of 1 and log that value. When it goes to the load, when the load logic works, you also have to log the count of 1 or count of star. Now you have to write one bash sh script to read the source log file. Let's assume this is s.log. This is target t.log. Okay. You basically compare s.log entry with t.log entry. If the diff is equal to 0, then the recon is successful. If the diff is greater than 0, then something is wrong. Okay, then the source has more data, target has less data. It will may not be less than 0 because target will not get more tuples. That's pretty rare. You will get more tuples typically in the source rather than in target. Okay. Now, when you do this comparison, if you have lesser data coming to target, it means then you have to log additionally the PK values, the primary key values. Okay. Now, as a second step in recon, you have to compare the primary keys. List of primary keys which are not reached the target. Whatever primary keys which are not reached the target, that is the delta which is missing. Okay. So this is how typically batch scripts are written to read the logs to do the recon from source to target. Okay. So in this session, we have looked at observability, reconciliation, how observability is maintained through sensing jobs, heartbeat jobs to bash files, and recon on typical data products as an example using bash HS files. I'll give you a very simple homework. It's not to just harass you, but it will help you learn better. You can write a small .sh file like 5 to 10 lines to read your own operating system logs. I'll give you paths of your operating system. If you're using Windows, I'll give you the log locations. If you're using Bash, I'll give you log locations. Just read those logs and print the messages so that you understand how the sensing job works. You can also write your if and else logic and make it complicated. So I'll prepare a simple homework and give it to you. Maybe you can spend 1 or 2 hours sometime by mid of next week to understand how to write a simple sensing job using a if and else condition by reading a log file on your own machine. Okay. Any questions? This is what I wanted to cover in the current class. Any questions?
No, sir.
Okay. Okay, great. So I'll share the assignment. I'll share the homework sometime tomorrow, and I'll also share the assignment of step-by-step guide of setting up Docker, so that you can do it in Teams and then submit. Okay, I'll publish both the classroom URLs, so that I'll share it with Ashish so that you can start working on it. Okay, great. Thank you. That's all I have for today. Have a great day.
Thank you, sir.